Hello, this is example 2 from the pre-calculus part 2 textbook. It's found on page 811 and 812 in your textbook. Excuse me, 809 and 810 in your textbook. What we're trying to do here is to try to do systems of equations. Now, there's no easy way to actually do this. If you're trying to solve three equations that have three variables, there are different methods that we can do. Substitution is one of them. Elimination is another one. We can do matrix math and do that. And so this one is literally called an augmented matrix, and we wanted to show you. It's actually called the Gaussian elimination method. But if you look at your actual linear system, you're going to turn that by looking at the coefficients. You're going to turn that into just numbers. So you have the 3, the 1, the 2, the 1, 1, 2, the 1, 3, 2. And then if you'll notice over here at the right, you have the 31, the 19, and the 25, which you can see you have a line and they're translated there. Now, step 1 is just turning it into what's called an augmented matrix. That's step 1. Step 2 is that you're going to use matrix row operations to help you simplify the row echelon form with the 1s down the main diagonal for upper left to lower right. That is called your main diagonal. So it's this one right here. Okay, that's considered your main diagonal. And what you're trying to get in that is ones. You want one in every one of those particular columns. And you want zeros below the ones in the first and second column. So in the first column, we're going to try to get this to be a 0 and this to be a 0. And in the second column, we need this one to be a 0 for this method to work. Okay? So to get 1 in the first position, we're simply just going to exchange row 1 and row 2. I could have done that as well with row 3, but this particular example chose to exchange row 1 and 2. So when I do, these two right here are literally going to switch, as you can see in this picture. I'm just switching them. Now there is a 1 in this first column like I wanted it. Now, as you can see here, we've got to get 0 in the ones below that. Now, how do we do that? Well, to get a 0 there, which is now a 3, you're going to multiply the top row by -3, and then you're going to add the two rows together. So that's what it's trying to show. Notice that down here in a little bit expanded form, the 1, 1, 2, and the 19 are not bothered with. But to replace the second row, you're going to multiply the first row, this one, by -3, and then you're going to add it to the second row. And that's what this is showing. So it'd be -3 times 1, then plus 3. Of course, that's going to give you a 0 here. In the second row, because you got to do it to the whole row, it's going to be -3 times 1 plus 1, because that's what your number was there. And together, that's going to equal -2. So this row becomes a -2, or second column. And then finally, if you multiply the top row by -3 times 2, because that's a 2 there, and then you add 2 to it, because this number was 2 in the second row, that ends up being -4. So now at least we ended up, and you're going to do the same thing with row 3 as well. You're going to multiply row 3 by -1. I'm sorry, you're going to take the top row, multiply it by -1, and add it to the bottom row, which is what this is showing here. And together, that's, again, it's going to give you a 0 in this space right here. But it also gives you a 2 for the second one and a 0 for the third one, and then ultimately a 6 for the augmented part over there on the right. Okay? Now, the next step is that we've got to get this middle column, the one highlighted in blue here. We need to try to get it. We want it to be a 1, a positive 1. So the best thing to do here would be simply to multiply row 2 by 1/2, or divide everything by 2. And that's what they've done. They've simply just taken this second row here, and they're dividing everything by 2. If I do, notice the first row doesn't change, the last row now doesn't change. The only thing that changes is the middle row. And if I took half of all this, half of 0 is still 0, half of -2 is 1, half of -4, I'm sorry, they're taking a negative half, my bad, because you want that to be +1. So half of -2 becomes +1, half of -4 becomes +2, negative half of -26 becomes 13. So this is the only row right here that actually changed. But you can see slowly but surely I'm getting what I need, and that is the main diagonal needs to be all ones, and the what's under them needs to be zeros, which are these three right here. Okay, so our matrix row operation have resulted in this right here. It's just been recopied right here. Okay, now we need to get that bottom position, which is now a 2 right here. We need to get that to be a 0 also. So the only way that we're going to do that is we're going to replace row 3 by multiplying row 2 by -2 and then adding them together. Okay, so if I multiply row 2 here by -2 each time, and then add it to row 3, which is what these were, then I'm going to end up with a 0 like I wanted. But it also turns this last one right here into a -4 because of this right here. This turned it into a -4. Now ultimately I need to turn that -4 into a 1. So I'm literally just going to divide this row right here by -4, or what they call -1/4, multiplying by -1/4. Okay, dividing by -4, multiplying by -1/4 is the same thing. So if I multiply this whole row by -1/4, then I'm going to end up, as you can see, with 0, 0, 1, and -1/4 of -20 becomes a +5. Okay. Now, I have what I wanted, which is a 1 down the main diagonal, as they call it, and zeros underneath each one of those columns. Now, what that translates into is, if you look at this augmented matrix now, if I were to turn that back into an equation, that represents 1x plus 1y plus 2z equals 19. The second row represents 0x plus 1y plus 2z equals 13. And the third row represents 0x plus 0y plus 1z equals 5. Now, that means that z is 5. Okay. Now, I've recopied a little bit, so let's ignore that part right there. Excuse me for this. Now, let me extend this page. Now, what we're going to see, if z is 5, then I just simply take 5 and I plug the 5 in right here. So y is going to be, or y plus 2 times 5, because I know what z is now, is going to be 13. Well, that's the same as saying y plus 10 equals 13. Subtract the 10, y is going to be 3. So now I found z, I found y, and I'm going to take those to the first equation, which is x plus y, which we know is 3, plus 2 times z, which we know was 5, and all of that's going to be equal to 19. So I really end up with x plus 3 plus 10 equals 19. That's really x plus 13 equals 19. If I subtract the 13 here from both sides, then x is going to end up being 6. So I have found all three variables here. The x needs to go first, then the y needs to go second, and then the z needs to go first. So the answer to this three systems of equations with three variables and three equations, the answer that would solve all three of those at the same time would be x equals 6, y equals 3, and z equals 5. Okay? And this is called the Gaussian augmented matrix method. I know it's a long process. These problems take a while to actually do, and you have to know your math pretty well to be able to do these. But this is a method, and of course this is pre-calculus part 2. So thank you. I hope this was helpful.